3, 2, 1. Hi everyone, in this video, pretty short one, we're going to be going over example 1 in the Module 5 lecture guide. So in example 1 it says, in order to investigate how many hours a day students at their school tend to spend on coursework outside of regularly scheduled class time, a statistics student takes a random sample of 150 students from their school by randomly choosing names from a list of all full-time students at their school that semester. The student finds the average reported daily study hours among the 150 students is 2.23 hours. Okay, so number 1 says, identify each of the following by describing it or stating its value, whenever it actually has a value. So A, the population of interest. Who do you want to learn about? So this statistics student wants to learn about students at his or her school. Okay, so then that's students at the school. B, the sample. Okay, who did you actually go talk to? Not the whole big group, but what was the smaller group you actually talked to? Okay, well, in the sample, we ended up talking to 150 randomly selected students. What's the parameter of interest? All right, well, remember, the parameter of interest is how do I measure something about the students at the school, because remember, that's the population, to try to answer my question. And this is nice because the question directly gives you what the parameter is. Go back to the question. In order to investigate how many hours a day students spend at their school, this is quantitative, right? I'm asking how many hours. How do we deal with quantitative data? Well, right now we look at the average. We just want to know what's the average of these students. And so that just tells you the parameter of interest will be the average hours a day spent on coursework outside your regularly scheduled class time. Boom. So you can really just take that right from the question that you want answered, but you just have to use average. Again, it's quantitative data, so we know we're using average or mean. And what's our statistic? Well, it's just in the problem. What happened to your 150 students? So you go to your sample and you look for that sample. What did I end up learning about them? Well, I learned that they reported, on average, to work 2.23 hours outside of class every day. Keyword is reported. We'll talk about that later. Okay, so number 2 then says, explain whether or not you believe the sample is representative of the population of interest and why. So what does it mean for the sample to be representative of the population? Well, go back up. So we're going to scroll back up here. Here we go. Watch your eyes. So it says a sample should have the same characteristics as the population it is representing. Okay, so let's think about this. We want to make sure our sample of students, our 150, have the same characteristics as the whole population of students. Right? So think about this, and you think about yourself. If you were going to go try to figure out the average hours spent studying, right? If you didn't do this by randomly selecting students, you might just go talk to people that you know. Talk to students you're friends with. And what could happen? What could be the problem with that? Well, if it happens that your friends, the people you know, have similar study habits, possibly to you, right? Then you might only be getting the characteristics from those students. So maybe you study a good amount, right? Maybe you're higher than the 2.23, and most of your friends also do. Well, there is going to be a proportion of students who doesn't study as much as they should. And if you're not friends with any of them, then you're never going to get their answer in your data, right? They will not be represented. And if they're not represented, guess what happens? In this scenario, the average you calculate from just you and your friends is going to be higher than the actual population parameter, because you're not even giving the students who study less a chance to be part of your sample. So that's why it's so important to randomly sample, so that every group gets represented. The people who study a lot, the people who study a little, the people who study some, everyone needs to be represented in the sample. They don't need to be in the sample, but they need to be represented in the sample, right? So let's go back down. Watch your eyes. So let's go back. whether or not you believe the sample is representative of the population of interested Y. Well, how did we get the sample? Go back to the problem. We took a random sample of 150 students. What does that mean? If we take a random sample, then we can be pretty confident that even with some randomness in there throwing us off, our sample does a good job representing the population. And what can we say if that's true? If that's true, right, then what we can say is our statistic should be a pretty good approximation for the parameter. Right? So both those things we can say. So go back to the question again. Do we believe our sample is representative? Yes. Why? Because we used random sampling. That's how you get a representative sample. You use random sampling. So the key piece is that you told me, let's random sample. That's exactly why we can say it's representative. So this is it. This is the big piece of this new module. And so what are you going to see with questions going forward? Well, I can still, with this whole question, ask you a bunch of things. Set up the null hypotheses, what's the variable, find the p-value, find the standardized statistic, give me a conclusion. But now we can take the next step and say, okay, you have a conclusion. Can we even apply it to the population? If you randomly sampled to get your group of people to go talk to, then we can say, okay, not only do I have evidence for the alternative here, maybe that's a conclusion you made in this problem, well, I can say I can take that and I can take that conclusion to my population. So I can feel confident that I've got evidence for the alternative, not just for my 150 people, but also for my entire population of people. All right? Pretty crazy idea, but it works, and the important piece is random sampling.